A very good morning. We are privileged to have 6G Leadership Tech Talk by Mombasawala sir. He has been the leader in the tech instruments and he has more than 37 years of experience in the various technology domain in the field of electronics, 5G, RF. And more important has been that test instruments vendors are always ahead of the other technology developers. So I think it's will be based if we hear, sir, on the leadership being provided by Keysight in this institute and how they perceive the 6G technology. So rightly he has given the name as 6G city. So I invite just for a brief uh, comments or remarks by Professor David Kwelpillai, our chairman as well. And then we'll hand over. Sir, to you now.
Good morning, everyone. It's indeed a pleasure to welcome you, to join Mr. Pathak in welcoming you to this 60 Leadership Talk. Again, I would like to thank Mr. Mombasawala for the opportunity to hear his insights and his expertise. And as Mr. Pathak has mentioned, as developers of technology, we rely on test instruments. We should never forget that they are actually ahead of us in terms of developing these test instruments so that we can then develop the technology which goes behind. So they are actually very much at the forefront of technology development, understanding the systems and trying to develop the test instruments that we can then build systems on that. We also had the privilege of hearing Mr. Mombasawala at India Mobile Congress last year. He gave an outstanding talk, and right at that time we had requested him, saying that we would definitely like to request him to share his expertise with the broader Bharat 60 Alliance community. And he has been very gracious to accept that invitation. So, Mr. Mombasawala, we are looking forward to what you have to say to us. Thank you once again for the time that you have taken to give this presentation.
Thank you, sir. Now I welcome Mr. Mombasawala and I have given the presenter rights to you, sir. So now you can move the slides. Yeah, please.
All right. Good morning, everybody. Thank you, Pathak ji, and thank you, Professor David ji. It is always a pleasure being at a forum like Bharat 6G Alliance. You rightly said, the test and measurement companies are a little ahead of the curve because we have to deliver before people start testing. So what I have done in my presentation is develop a 6G city as we foresee the technology, as it evolves. Yesterday when we were attending 6G Summit, International Standardization Summit hosted by TEC, it's quite clear that the timelines and the roadmap for 6G is more, crystallized than it was before. People are committed to it. All companies have signed on to it, saying that, they will adhere to the timelines and they will probably invest. We are seeing a major traction from the market in terms of the test bed purchases. So what I have done is I have put up all this together and developed the city, which we call it as a 6G city. Now while we develop 6G city, we have to remember what we have in history. So this 6G city is under construction. It is being overlaid on the existing 5G city that we already created, or the 4G and 5G infrastructure that we already created. This 6G is supposed to fix up the issues that we had in 5G. It's also, supposed to provide those monetizing capability or the service capabilities that we have been striving for in 5G and 5G Advance, and should be enhanced in 6G. So the 6G city task is an uphill task, and that's why the roadmap or the timelines are huge, and people have to do a lot of experiment before they come up with any kind of firm systems or deployment. So let's examine in terms of what did not go well in 5G, where we need to fix it, we need to reinforce it, and we need to develop those things beyond what we have developed. So in 5G, things worked well for FR1, but not for FR2. Why? Because less than 10% of the device supports it. It is very expensive. Since it's operate in millimeter wave range, the propagation issues are something that we could never solve to an extent where the systems can be readied, and the infrastructure gets extremely costly. So it came up with a good speed, but it went back with a similar speed, with people not committing to the investments. So when we go up the frequency beyond 6 gigahertz band, we have to remember that there are challenges which are associated, and it's kind of a be much takers because of the deployment cost and the operating cost. The second one that did not work well is 5G was supposed to provide full benefits, including 5G Advanced and Red Cap and other features of release 16 with standalone mode. Standalone mode would have provided a very comprehensive end-to-end kind of a performance in 5G, but it did not happen. You see here, out of only 73 out of 349 5G MNOs are basically, on standalone, and remaining are using 4G network still as for control. The it truly did not pick up. I mean, people were wary of investing completely on 5G SA, and they actually overlaid 5G on 4G itself, because the return on investment and the technical complexity of doing that was pretty high. And the third thing that we want to notice in this is about the MNO debt. Okay, most of the MNO, that is mobile network operators, they borrowed a lot of money to invest in 5G, but the return is not commensurate to the kind of investments that they have done, and they are now facing huge amount of debt. The ARPU has not substantially increased. Probably 5G is perceived more as a bubbled up version of 4G, providing you probably a higher bandwidth, but it truly could not give that differentiating element to people with which they will be able to pay for services. And there were other reasons why the ARPU could not increase, but it truly did not monetize the way we envisioned initially when we roll out 5G. So what is it that we have to do going forward in 6G? It's a very clear message from all MNOs that if you build a technology in future, it has to have a reduced cost, and it should have enough service element to monetize and grow the revenue for them. This is imperative. This is a must, for them. So reducing the cost and growing the revenue is a mantra that we have to adopt in 6G, to make sure that we just do not provide a connectivity that we have been providing in the past for data transport, but we need to provide something extra so that you have those services which can be monetized. And there are plenty of services that we are thinking of, which we'll see in the 6G city build up. But these needs to be clearly monetized. Somebody should be willing to pay. They should see a value and benefits to it. Now, for that to happen, we need to strengthen the network, and we need to reduce the cost. Now, one of the things a survey indicates that almost 57% of the cost of energy is paid by the MNO in operating RAN network. So you can imagine the amount of energy that is consumed by the network operators, and if we can reduce RAN operating energy, that means conserve energy in RAN, that would be a substantial reduction in the operating cost. At the same time, there has to be some mechanism in which networks and the operations are simplified through AI mechanisms. Let network learn the history. Let network be aware of the operational model. Let it be taking the decisions by itself, so that we don't need intervention. We can have the lighter way of doing things, because the history is known, the system is aware, and they are able to decide based on some of the parameters that are seen at an instant of time. So if we get it AI enabled and we conserve the energy, then we will be able to roll out the service and reduce the cost. Now here there is some dispute in terms of, people say if you invest in AI, if you have a lot of training models, trained models deployed even for inference, you actually end up consuming a lot of energy. But to conserve the energy, AI becomes imperative because the decision has to be well aligned to the operational model. And this is an equation that we have to solve. The break even point that we will have to figure out, which is an optimum point. But in time we will have to do it, and this would remain a guidance for all of us to deploy in 6G. Going forward, we will have to be cognizant about what the decision is taken in 3G workshop, first ever workshop that happened in Korea almost a year ago, where in a common voice everybody said that there has to be something that needs focus in 6G. There are a lot of enthusiasm that we have in several technologies in 6G that may not be promising enough at this point of time to monetize. So let us de-accelerate some attempts and let us accelerate some of those developments with which we should be able to reduce the cost and optimize revenues. So cost reduction or increased efficiency techniques are spread around these areas. So let's improve on the spectral efficiency enhancement, network energy saving, RAN simplification. We need a communication simplification in RAN, coverage enhancement, and multi-rate spectrum sharing. And all, if you see here, are related to RAN operation per se, because that's where you have maximum of focus right now. And then let's spread out services. Let's bring in ubiquitous coverage. Let's bring in sensing is promising, but we will have to figure out what we really position in the sensing. Okay. And ubiquitous coverage through probably NTN. Let's make sure that AI as a service is deployed. Now, there is such a big disillusionment in the industry with AI as a service. Now, will we be using RAN as an agent for inference for AI, or will it be cloud centric, or will UE and cloud together will harmonize the inference and provide the services? These are the questions that we will have to solve going forward. But this, I believe that AI as a full-blown engineering service, not just the search element, would be a revenue increasing, element in the network. And of course, improvement of network APIs. That's what we believe. There are certain things that we think would wait for some time. For example, sub-terahertz frequency, unlicensed band, V2X, particularly enabling automotive applications, repeaters or RIS, and then multicasting technique, particularly the similar kind of technique that we used in IPTV, making use of rendezvous point to distribute the streams. Similar kind of functions can wait. Let us have the connecting and the intelligence element built in with AI as a service and improvement in efficiency. So with that in mind, we are trying to build the 6G city. And what I have done is the advancements that we are seeing. We are ourselves not developing any equipment. Keysight itself is not responsible for developing equipments. We only make instruments, but we deal with all the customers. We deal with UE makers, we deal with RAN developers, we deal with or we provide instrumentation for core developers. We also work with hyperscalers for their performance optimization, AI benchmarking, etc. And we realize that if we bucketize the development and map it onto 6G, then it comes into 4 different categories: Spectrum Valley, Twin Town, Network Plaza, and AI District. And if we neatly implement all of this, it will take us to the future heights, the kind of heights that we are looking at 6G. It is supposed to, put in the kind of performance metrics that we envision in IMT 2030, but we will have to fix all of this. So what is it that we want to do in each element? In subsequent presentation, what I'm going to do is I'm going to cover these 4 areas and subtopics within these 4 areas. The first of which is Spectrum Valley. Now the black slides have started. In this black slides, you will see some of the blue slides, which says that the things are in the research stage. and some of the slides which are pink, which would say that they are in the product development stage. Ones are in the product development stage, and the blue ones are in the research stage. We are still trying to figure out what needs to be done. No decision has been made. There is some level of throttle that is in the pink area, where people think that yeah, there can be some implementation of the system. So these are the 8 topics that we think about in Spectrum Valley. FR3 subterahertz related to frequency, then coverage with MIMO, ultra massive MIMO or cell free MIMO, and then new waveform development where there is a maximum push right now, because we have to make sure that sensing also has a good waveform. We also have to understand that a huge Doppler immune kind of a waveform is required for NTN, and a new waveform might have to be embedded in 6G communication, and then improved KPIs, full duplex, etc. For each of this, I have a slide, but I'll go through some of the slides faster than the other, depending upon the interest and the capabilities that are prevalent in the market. So FR3 is a band which is of paramount importance. We have been dealing with sub 6 gigahertz in the past, and we know how the propagation happens. The area of interest within sub-C now we call it as upper 6G band, which is 6 to 7.125, is also of interest. Why? Because the propagation is very similar. The network or the designs are very similar. Even FR3 band, of course, not official name, but FR3 band, which is from 7 to 24 gigahertz, can be pretty promising, because 200 gigahertz clear, 200 megahertz clear band or 400 megahertz of clear band on one carrier can be well served in this range. This is what we feel, and knowing our designs in antenna, front end, etc., it will be easy to replicate in this frequency. So what are our customers saying? They are trying out several propagation models within this area right now, FR3 band, and this probably can help us provide that needed bandwidth with compact antennas and a better coverage, if we adopt this frequency. But this frequency allocation is yet to happen. We will have to make sure that we start experimenting with the systems and the component before frequency is allocated. So these are the challenges that these are the benefits that we have. But at the same time, I see that we will also have to fix some challenges. For example, the biggest that comes to my mind, even in all communication, pervading the entire band from FR1 to FR3 to FR2 also, is the interference management. Interference management is becoming a big problem, because most of these devices are operating on a zone which is now a non-linear zone. They are being pushed to the non-linear zone, wherein the generation of harmonics and the suppression of harmonics has to be proper. So generation of harmonics of multiple of carrier frequencies, leading to a lot of interference of unwanted signal, and this gets multiplied when you get into a component carrier or carrier aggregation, etc. So we will have to attend to all of this going forward. Okay, but this band remains promising, and that's where most of the people have the attention. The second one that we have seen is the sub-terahertz frequency. Again, a lot of research happened, but people say we will have to wait. Why? Because the equipments are going to be humongously costly and difficult to maintain. While we can have a chunk of bandwidth of up to 8 gigahertz or 6 gigahertz, and we can utilize it very neatly, but the applications can be limited in a widespread communications. I can think of an example, like when we talk about automotive radars operating at 77 gigahertz, that's where we have a good bandwidth available, 6 gigahertz or 4 gigahertz. In sub-terahertz band, we will have a better bandwidth probably. But do we need it at this time? Probably no, and that's why we'll wait for some time. But this has a promising outcome. So we'll wait for some standardization to happen going forward. People have experimented; they have some products available. There are some mechanisms that are in place for propagation with sub-terahertz also. But truly, this will come into 6G network in some time. Okay. The second topic is on ultra massive MIMO. People also call it as extremely large MIMO, giga MIMO, etc. And it is quite promising. As we go up the frequency, as the wavelength reduces, the antenna gets smaller and smaller. And if you see here, you can pack up a lot of antennas that can give you pencil type sharper beams. That will also help you, put your or focus your energy for a better propagation, etc. And then it can actually allow you to have a better coverage. That's what we feel. Notwithstanding the antenna design, integration, or channel estimation and feedback, etc. These are the things that we will have to fix. But this is where we have maximum focus. If we really want to enhance the coverage, if we really want to have that blown up kind of a bandwidth, or speed that we are looking at, this is what we should look at. So this is where many companies are committed, and we expect this market to be close to around 40 billion by 2029. That's what our estimate of at our companies. So you can imagine the amount of investments that are going to happen in ultra massive MIMO. And not just that, people say that like you have coverage through ultramassive MIMO, there should be provision in which there should be a seamless communication as people move between different cells, and let the cells be very small so that you are latched to multiple cells at a time. Okay, cell-free MIMO. Why MIMO? Because you can have the similar arrangement that we had in 5G and 4G called coordinated multipoints. You can have the feed from different antennas together. Okay, and I am aware of multi-point TCP protocol which can actually enable this, but it is yet to happen. If we can have very small size or femtocell size where people can be covered in an arrangement where you have multiple cell coverage, then it looks like as if there is no cell. And that's where some of the researches or some of the developments is happening. So it's still in the research phase. We expect this to be a foundational technology in 6G, because this we believe would be providing similar arrangement that we have in Wi-Fi kind of arrangement. There's somebody who is willing to ask the question. You can unmute and ask the question, or we may want to reserve it for the end, just to maintain the flow of the presentation. Okay, so I'll move on. Let's look into new waveform. Now this is a hot topic. Okay, is OFDM going to stay? Will it be dislodged? Will new waveforms be in place in 6G? I believe OFDM is going to be there. Okay, it is not possible to remove OFDM, considering that the deployment in 5G is on it, and we have been using it. We are comfortable with it, but we also have to be mindful of this fact that OFDM is not a radar waveform. It is not a waveform with which we'll be able to do the sensing. It is not so efficient in capturing reflections. And at the same time, it is not so well designed to accept Doppler for NTN application. So there are some candidate waveforms. I envision, and our company also envisions, that probably these newer waveforms, depending upon the services, will be encapsulated in the 5G OFDM itself with a new structure that will emerge. Okay, and if that structure emerges with all of major of these candidates, depending upon the services, is encapsulated, we will be able to harness the benefits of these waveforms. For example, OTFS would provide you a good Doppler resiliency. We will be able to manage interference, etc., if we design properly, and we'll be able to accommodate a lot of services. But then it has a lot of design challenges, so we'll have to wait. We'll have to make sure that we prove these waveforms up, make them candidate ready for 6G, and then this is something that the entire community in the world accepts, and the study items are in place. So new waveform is another one, full duplex. We have been doing full duplex, okay, in the past, but in 6G, how is it envisioned? Is we use it on the same frequency, the up and the down, the upward communication, the uplink and the downlink communication frequencies are same. And what if you use the same antenna? You have a severe amount of self-channel interference, because there will be a feed of transmitter to receiver. If we have this interference cancellation, and it is not very difficult to do, we can have the same frequency used within the same band. Okay, same band frequency can be used, and this is what we think can happen in 6G. Right? And then dynamic spectrum sharing is something that is of the 5G days. We want to make sure that you have 6G and 5G spectrum being reused, reshared, etc., depending upon the combination that will emerge going forward. This is imperative. We cannot be wasting the existing available spectrum. We will have to make sure that we either reform it or reuse it, and this dynamic spectrum sharing will be eminent. We will have to work out several combinations of frequencies in this. Okay, and then lastly, improved KPIs. Now this 6G KPIs are similar to the one that we have in IMT 2030. Okay, yesterday in the in one of the presentation from Ericsson, I made to understand that while these are the vision or the desired values, it will be diluted. Like I pondered on the position accuracy. Instead of 1 to 10 centimeter, probably it will be between 50 to 70 centimeters, because the designs will take us to that limits probably. And then the latency will not be probably 1.1 millisecond, but let's worry about 1 millisecond. If we can truly achieve 1 millisecond, then it would unlock a lot of new services. So this will be revisited. New KPIs is getting revisited by pondering on the system requirement and the development, and then how much of hardware, how much of software, and the energy that we can put. We are trying to work it out, but these KPIs are something that we need to clearly define and work on. So this is what we see. A good part is at least people are agreeing on some of the upper limits of the KPI going forward. Okay. So this covers us on the Spectrum Valley part. Okay, the other topics are the Twin Town, Network Plaza, and the AI district. So I'm going to the second part now, which is on the Twin Town. Now, why twinning? It is extremely essential because we realize that up to this point, we were deploying, we were designing the network, we were doing some planning, we were deploying the network, and we were then doing a lot of drive test, capture data, and then try to optimize it, which was kind of post deployment optimization. In 6G, we need a lot of data, we need a lot of optimization, and we need to create a twin, figure out what are those optimizing parameters, both at the component level and the system level, and extend it to the network level, so that we do not redo the things that we have done in 5G, and don't end up with a level of cost that we have in 5G. Okay, so digital twinning is imperative. Now, what do we exactly do in digital twinning? Many people remain confused between few jargons. One is the emulation, second one is simulation, third one is digital twinning, and the fourth one is metaverse. We are going to focus only on two of them, and that is simulation. Simulation is a subset of digital twin. Simulation is basically kind of a design that you want to do with software. It is designed based on some of the library parameters, but digital twinning takes care of enhanced simulation with historical data that is fed into the simulation, and use those algorithms of simulation so that you have the outcome, which is then compared to the real world. And the delta is then corrected again with those algorithms so that you have the perfection in the system. So simulation is a one-time effect. Digital twin is a iterative effect till you achieve the perfection. And this is what we would attempt to do in 6G. And where do we want to do it? So we want to do it at RF level first. And this is where most of the focus is there on industry right now. They are trying to figure out how can we embed AI model based transmitter and receiver with enough knowledge available in both of them, so that they can adapt themselves as per the channel conditions. So what we want to do is we want to actually have a digital twinning of transmitter and receiver based on the channels or the propagation model that we have, and then we are trying to design them in a way that they adapt themselves to a condition which is as per the channel. Okay, so this is the first step. And this AI algorithm is extremely important because the amount of data that you actually capture in the operations, and we have a lot of data, operators have a lot of data, they have the data of operations. It's just that we need to actually filter it, or we need to distill that data and put it into a form of a knowledge which can actually train these kind of transmitters and receivers, and create those kind of models. So if we do that in a digital format first, train these models and see how transmitter is able to react to different channel models, then we will a transmitter and receiver both, then we will be able to optimize the operations of transmitter and receiver in a link. Now, why do we think we are doing this? One of the things that we know is, okay, if you have a bad channel condition, the obvious way is to elevate the power. If you have a higher power, you have the better coverage, etc. Right? Now that again consumes immense amount of energy. So where does it stop? We need to figure out the mechanism in which we are able to tune transmitters and receiver and operate in a noisy condition with a lower power. And that's why we are doing all these kind of things in a digital format. Not ending at RF level, we also want to do it at a channel level. So this is a diagram. If you see in the bottom, there is a street which is shown. That means we have the whole of topology mapped. If we can have the known topology by doing a ray tracing, so we do a ray tracing, we figure out different objects in the propagation, we put it a digital model, and then start putting the UE and the base station, and then figure out how this propagation works. And based on that, we make sure that our operations is optimized. This would be extremely essential for newer use cases like MIMO and ISEC. For normal communications, it is the way we have been operating, and probably our experience might help. But in newer services, we will have to optimize further. Not just transmitter and receiver, but the way in which it operates in the actual physical locations. So we will have to make sure that we digitize this. Okay, and then not only that, what is envisioned is digitize the whole city and put it in a format that would allow you to have the physical network and the network applications adapt to that digital twin that you have made. Okay, so I'll just give you an example. What if an operator has the whole of a digitized digital twin of Delhi city, and it has all the structures known, the concrete and the steel of all of this structure, the propagation model known, and then you put UEs or the service elements at different locations, a base station at different locations, and this overlaid onto the digital model is going to give you the whole mechanism or the performance of the network that you deploy or operate. If you do that first, you will not be worried about the operations much when it gets deployed, because that would help you minimize risk, would help you optimize on your performance. So this is a long story. I mean, it is not easy to digitize the whole city in a digital format, in a digital twin format, and then do this exercise. But we are starting with the RF link, and we are going gradually to some elements of the network and make sure that it operates there. Okay. The third element that I want to talk about is the network plaza. 5 things in there. I'm going to focus on 2, 3 of them, not on core and security part. And we'll see that. So it consists of these 5 elements. Let's talk about NTN first. Enough has been said in NTM in many forums. It is essential. We want some LEO satellites. We want a dense constellation of these satellites at maybe 300 kilometers.
ब्रो
And then,
तुम बोल
yes.
रहे हैं 200 या 250 ग्राम ना कलाकंद भेज देगा वहाँ पे 20 बड़े बच्चा जब भी टाइम मिलता है और मैं
So,
क्यूआर हाँ क्यूआर कोड भेज
Anurag ji,
दीजिए
can you mute? Anurag ji, can you mute your phone? Yeah. Yeah. Sorry. So NTN is basically to deploy for providing ubiquitous coverage. Okay, it is not to provide the broadband coverage, and there is a lot of work that we will have to do. Uh, when I was talking to a lot of satellite folks, particularly those who are entrenched in satellite, they have told me that EPFD, effective power flux density, is almost 80% consumed by the geo satellites and the existing operation of satellite. That means we are just left with a small amount of play of 20% with the constellation of satellite that we would deploy in NTN. That means we'll have to keep them pretty low, and we will have to keep the constellation quite dense. Otherwise, we will end up we will end up with a lot of interference from the existing deployment, and that's what we will have to solve. So it's not just about solving the propagation link between the feed and the user link, but it is also about solving the network constellation problem. So the regenerative satellites that we think we'll be deploying would provide us enough inter satellite communications and the links with which we'll be able to reach the end user. Lot of investments and a lot of work is required in NTN. It's not going to get settled so easily. This is very promising. I'm very upbeat about it. I'll see that this would happen sooner than we envision, because this is ISEC or JCAS is what is going to give a good monetization to operators. If we can have the gesture recognition, fall detection, 3D imaging to begin with, even in a monostatic or biostatic mechanism, it should be good. Most of the people have UE in their pockets or along with them, so the active element is there. We don't have to worry about the passive element at this stage. A lot of services can happen on the active element itself. But if ISEC is successful, it will also unlock a lot of new things like easy sensing it through V2X, etc. So ISEC is where we have a lot of promises. And then RIS, although RIS is something that people say we'll have to wait, because we as a part of 6G sandbox program that we have in Europe, we tried deploying some RIS, and it takes a long time to actually align this RIS. We have done it in millimeter wave band though, but it takes a long time to align, and then it also requires a very good amount of calibration every time we deploy the RIS. So there are some deployment challenges. RIS technology is very promising because it will allow us better coverage. It will allow us coverage in the areas where it is not proper, but the deployment challenges are pretty high, and that's the reason why probably people say let's wait for some time, let's see if NTN provides a better coverage. RIS probably can be used in those areas where even NTN cannot provide the coverage. Let's see how it unfolds. But I see that RIS is going to get standardized pretty soon. Currently there is no standard, but it will get standardized and it will be a part of the network going forward. Okay, I'll skip some of the core and security slides because we will not be having enough time to cover them. We will have to take some questions also. And the last point that I want to talk about is AI district. Now these days you hear AI everywhere. Okay, everybody talks about AI, and many people talk about AI without even knowing what AI would mean. But in AI, in network, we will have to very carefully understand how AI is going to enable, because each time we deploy something on AI, we end up consuming energy, we end up consuming a lot of resources. There is a lot of computation power needed, there is a lot of inference engine that we need, and also you need to have a robust trained model with probably a federated learning. If not federated learning, probably operator would say that, okay, I have my data, at least I have trained it on my data, and it should work in my network. So how does this get universal? How do we make sure that AI operation in the network is more or less following similar trajectory that we have in the other standardized operations, is something that we'll have to see. And people have started working on it, if not fully for the network, at least in optimizing the transmitter and receiver blocks. Okay, so I will just give you an example. As soon as you receive the signal, you have some EVM or the noise development in that. What if I can filter it out based on the history of EVM constellation, and I can figure out that, okay, this is a right fix for the EVM because my history in AI shows that this kind of noise accumulation has more probability of a constellation decode of this type. If we can do that in this receiver based on the channel estimation or the channel model, based on the channel estimation and the decode part, then it is going to work. Eventually what we want to do is we want to integrate all of this and put it as a neural receiver, AI neural receiver, so that it understands the whole decoding mechanism based on the noise conditions that has accumulated, and it is able to adapt itself to the channel conditions so that we can unlock these services. This is what we mean by AI. But if you want to deploy it into the receiver, you need a lot of filtered information, the information about several channel conditions, information about how receiver actually decoded it, and what was the proper decoded information. I mean, was it with error, without error? So let's eliminate those errored part and see where the cleaner part were extracted. So a lot of exercise of those data copies that we have to create for training these receivers are required. It's not just about hardware design and software write-up. It's about choosing the model, putting the appropriate data for the operator, and then have these receivers trained and then tried out so that we can say that these receivers are so adaptive that they will be able to operate in a noisy condition and will be able to extract the data. I see this is going to throttle, in a big way, the services like NTN also, because if we can extract the information on a very, on a signal slightly above the noise floor, with these AI trained inferences that we have in the receiver, then we will be able to do a lot of things. But there are a lot of questions to be answered. Okay, how the interoperability between various vendors are going to happen, how will it, how these algorithms play, are they explainable, what kind of model has been used, what data has been used, etc. So you'll have to work through all this, and there are no definitive timelines per se. Research and development is happening, but we will have to we will have to graduate to this level if we really want to optimize. Okay. The second one is the CSI compression. CSI is a big problem area. Yesterday, when Professor Buddhiraja was talking about CSI, he was talking that for MIMO applications, when you have so many of these kind of channels used, every channel needs to send the pilot, and then you will have to do the channel estimation. What if you have the AI algorithm which actually can have limited pilot set, and then from that you can do the channel estimation, etc. Here we are talking about that as well as the compression. What we let us zip the kind of AI data, CSI data with an encoder and decoder, and use those AI neural networks in a manner that we have a lesser pilots and communications that happens, and at the same time we are able to extract information. If we can do that, we can have a better MIMO. As you go for MIMO, you have a higher overload because of this CSI, and that may jeopardize the operations or may put an upper limit or a threshold of operations in 6G. So let's look into this CSI also. This does not have to do much with the energy saving. It has to do with the operational parameters in terms of how do we operationalize for better coverage and MIMO. So there are challenges that we will have to solve: better alignment, and reducing the overhead even for MIMO. Studies are underway, and if we can standardize in due course of time, which we will, okay, we will have a lot of testing which is needed, because people will have to have a unification of these kind of encoding and decoding mechanism, and they will have to make sure that the reference model that eventually emerges have to be well tested in the system. So we say that because we come from Keysight, so test it out, kind of, right? And lastly, AI RAM. Okay, while there are different things which are emerging in terms of RAN operations for or the RAN optimization of AI RAN is something that most of the people in industry talks about. They say that, okay, kind of AI learning that we have, let's put it on RAN and optimize the RAN primarily for energy and network coverage. So let's optimize the energy. Let us shut off the processes that are not utilized. Let's reduce those kind of operation of cells in at night, or probably at the times where the traffic isn't enough. Traffic is not that high, or the magnitude of traffic can be served with lesser number of cells and etc. Okay, right now we can do that, but not as adaptive as what we can have with AI, or the history of the situation that we can embed in the RAN. So it will help us reduce the network efficiency. It will also probably provide a better customer experience because we can optimize the network coverage. Okay, so we'll have to put certain algorithms and make sure that we optimize this network. There are three trends which are happening in market: AI for RAN, AI and RAN, and AI on RAN. So right now, people are talking about AI for RAN and not the other ones. Okay, because they people cannot do everything together. They have to do one at a time, and they have a limited investments today. More than technology, there are challenges of the financial investments also. It's more financial than technology, I would say. So what is AI for RAN? Okay, this is put in a diagram here. AI for RAN would mean that you put on RAN, the blue ones, all the mechanisms that you have as RAN, as AI for optimizing spectrum, cost, energy, efficiency, etc. Okay, AI and RAN is where you have the AI, already AI optimized RAN, and you have the core which works seamlessly. So that is a kind of a seamless operation of services with a very strong corroboration between the RAN part as well as the core part. And we would focus on it as the second part. And then AI on RAN, AI services completely on RAN with the UEs probably as agent for inference and all that. The architecture has to evolve, but the way in which people are putting the AI in the network as services, we think that it will emerge. For now, most of the services or most of the inferences is cloud based only, so it's central, but we will have to distribute it in the network at RAN, at UE, and other places to unlock several applications. I think of applications like holography, ISAC, and Industry 5.0, wherein we need that level of precision and speed, wherein we will need to have a distributed or a split kind of a inference, wherein AI on RAN would be beneficial. So that's a long story. We will have to wait for several years for AI on RAN, but for now, the 6G city is getting built. Okay, and it is getting built with 4 districts: Spectrum Valley, Twin Town, Network Plaza, and AI District. And these are the ingredients in there. All 8 elements in Spectrum Valley are in works. Few in the product stage, few in the design stage. In Twin Town also, many in the product stage, AI District and all that. We see at Keysight that these are the things that will continue to work for at least a year or year and a half till the standardization process begins, where we form up the things and go to the next stage. So the good part is the standardization process has begun, and the output that comes out of the experimentation in these areas would be a feedstock to the standardization bodies, and they will start standardization wherein many of the NEMs will be encouraged to start developing these products as we develop 6G city. So net, what is 6G city? 6G city will be overlaid on 5G. We will have a similar architectural setup as we have for 5G. We will have UEs, we will have RAN, we will have core, and we will have the content. And it is going to be overlaid on 5G. That's what we feel. But we will have to strengthen or enhance or redo some of the things. Okay, that's what yesterday Ashwini. I think Yashwini Kumar was saying that we will have to reinforce, redevelop, and something 3 R's that he used. We will have to do that. Okay. right? And these are last few slides. We have certain hands raised. I think Manoj ji also raised hands. I'll answer those questions. We are associated to a lot of forums, including Bharat 6G Alliance in India. So these are the alliances where we Keysight is a direct member and are contributing to the test part of how do we test 6G. And this is how it is. So I have one slide that I wanted to talk about, which is not there in this presentation. Now, probably Asta, you are not using the latest one, but let me just explain briefly about that. Okay, in recently concluded MWC, there is a new industry leader commitment that has come in. So what has happened is Qualcomm is taking the lead along with a lot of other partners, maybe 59 partners or the companies that are signing up, and these leaders are committed to 6G development towards commercialization by 2029 and 30. And there is an agreement, and these companies actually are not just the UE companies, they are RAN companies, they are also the core companies, they are hyperscalers also, they are also the companies which can provide the services in India. I see the name as Airtel. I also see Nokia there. I also see Geo there. So there are companies which have signed up for this. I have the list. I am not able to show that slide, but there are three key pillars: connectivity, wide area sensing, and high performance compute. They are going to work on these three pillars to evolve the architecture that is most optimized for devices, network, and cloud. Okay, so that they have the timely development of 6G standards, and they are able to validate the system for 6G specifications or pre-compliance by 2028 and start deploying the 6G system, make interoperable commercial 6G system by 2029 and 30 and beyond. So that's the whole objective. Qualcomm is leading because they feel that till 5G, what we have done. Yeah, I think you're showing that slide. So till 5G, what has happened is uh, uh, we have been talking about the KPIs for RAN or the operators, right? And then we could really not give the overall performance, end-to-end performance of any services when it emerges from UE till the termination at the cloud or retrieval of information from there. Bringing all these companies together and have their commitment and association in testing in labs or in the pilot or in the deployment would lead to a kind of a collaborated efforts with which we will be able to figure out the whole end-to-end performance. End-to-end is performance were truly not measured anytime before. Okay, when you transact from bank, you are worried about probably 5G network latency or coverage, etc. You are not worried about the upper layer stack also. You are not worried about how much delay would come in because of SSL or TSL decoding, etc. Right? So putting all these companies together is very exciting. I'm pretty excited about it that these companies have come together to figure out how we deploy need 6G network and we don't create the mistakes that we made in 5G. The ones that we see are in earlier slides are not repeated, and we gain the confidence of our consumers by providing them the services that they are expecting. Okay, next slide, Astha. Just I think that should be the last slide. Yeah, next slide after this. Yeah, I never end my presentation without the quotes. So these are the quotes that I like. This is the one that I added recently because I feel that AI is so disruptive and is so reprimanding to us that it doesn't leave any room for us to create mistakes. Okay, as system gets powerful, we will have to get more alert. We have to make sure that we actually do it well. So to err is human, to persist in error is diabolical. We probably can make one mistake. We already made mistakes and people pardoned, but in 6G, let's not make mistake further. People will not pardon it going forward. Okay, and the last one is when Mother Teresa Lisa was asked about what is the world's greatest disease, it's not leprosy or it's not tuberculosis, but the world's greatest disease is to be nobody to anybody. Okay, so thank you everybody. This is where I would want to end my presentation, a monologue, and we are open for questions. I see some raised hands. I think there are two hands
Yeah,
raised.
thank you. And I invite Mr. Manoj Gurnami Saab.
Hello. Thank you, Patrick Sam. Um, Good morning, everyone. Mombasa ji, as always, it's a great presentation. Your presentation reminds me of my college days. It takes me back to, these are beautiful slides. Thank you very much.
Yeah,
I
welcome.
was trying to take this presentation on my mobile, and there were at least two or three drops. This is despite me being in the outdoor environment. So my question is, in 6G, when we talk about this sub terahertz band, at KSI, what's your take? I mean, how mature are the channel models? Because there are aspects like diffraction, scattering. I mean, are we mature? I mean, what's your take at KSI for a
So
reliable
so
coverage?
yeah. So for a reliable coverage, it is like this. As long as we were wanting to cover it with our vanilla mechanisms, we were doing it well. As we started bubbling up the bandwidth, as we started getting into MIMO, as spectrum got denser, those reflections, etc., are leading to a situation where you have the coverage issues. Now, the coverage that you are not getting maybe a dark spot or maybe something, but what I'm pointing to is with the spectrum getting denser with these devices getting into non-linear range. Now that is very important. Why non-linearity is something that I want to build, because you want to build an amplifier which with a lower capacity and push it into non-linear range, because that's the only way in which you will be able to optimize your energy. And if you do so, you start generating a lot of harmonics. So now our play is not just about a carrier frequency, it is about a lot of harmonics that we are generating. And going forward, these new models have to emerge, and that's why people ask, there are no, I mean, we have the models, but people are now fine-tuning the models by putting variability in there. Let me create a superficial situation by inserting those kind of, distractions, deflections, interference, etc. in the model and test out my UE and the base station. So put a base station, put a channel emulator in between, put the model, fine-tune the model, make changes in the model and apply the coverage. You can do it for movement, you can do it for different dense condition, you can do it for different physical conditions, etc. But there is still a lot of work required. For operators, yeah, this is something that they will have to do. Both NEMs and operators, that this is something that they will have to do in 6G. In 6G, the effect will be more aggravated than what we have seen so far. So we'll have to fix them, and there has to be appropriate algorithms in the devices for interference cancellation as well as for better extraction of signal in a noisy condition. I hope
Thank you,
I
Ankur
have
Kumar.
answered your question. Yeah.
Yes, thank you.
Yeah.
Well, just I have one question. That how network control repeater that's play a major role in that 6G, because as 3 GPP are already standardized the network control repeater, and this is the one. Second one, the you have already talked about the RIS used in the NTN scenario. So can we use the network control repeater in the NTN instead of RIS, or can we use the both? I want to just your comment on that point.
So it is like this. NTN and RIS working together is very seldom. Okay, RIS will be used in the terrestrial network to deflect the energy. So they are not used together. They will complement each other depending upon how the deployment is done by the operator. Okay, so that's your second part. On the first part, you were saying something about 3GPP. What did you? Can you just
That is
rephrase
the
that question?
network control repeater. That is in 3GPP release 18 and 19 that about talked about that, and they also standardized this part.
Yeah.
And
So
this is
you know. Yeah, so those devices can be used. Okay, they can be in play, but they are yet to be deployed. I have not seen that happening in the network yet.
Okay. But the main problem is a network control repeater is a deployment. How steadily you can deploy. There are many papers that as I'm reading about this, there's a problem to how to deploy the network control repeater in this complete scenario. And the 6G though, for wider coverage, we definitely need a satellites and the non-treasure network part. Then the deployment scenarios to provide the better coverage and to patch out the where the dark side is there. So network control repeater and RIS can be used in both the part. So definitely I will go with that. And thank you for that
Yeah,
wonderful presentations.
yeah. So what I would suggest you is and suggest everybody that there are a lot of things that we have on our plate right now. Okay,
Yeah.
if we want to nearly do something better, let's start with some of them together and then do a digital twinning and gain some confidence. Digital twinning will still be digital twinning when we operate. Maybe we feel that something is missed out, etc. But it will not be that we have seen in the past, and that's why at Keysight, we continue to advocate for digital twin. A lot of our customers are convinced when we floated this idea of channel emulation. They said that it's a very expensive tool, etc. But when they saw the benefit and started doing the lab testing also, they realized that it is saving them a lot of time and cost. So I would say instead of doing everything together, which nobody can do, let's granularize this, and with this granularity, probably we will be able to evolve. Yeah, yeah. Thank you.
Thank you.
Thank you for the question.
So, Mombasawala, thank you very much for the presentation. I have one question. When you talked about non-terrestrial networks, I saw that you had all these satellites indicated. Do you also see a role for HAPS, the ones where we are at 20 kilometers and not moving, more or less of a stationary platform?
Yeah, so NTN does speak about HAPS. Okay, so HAPS has a role to play. It depends upon how you want to take it. So it has obvious advantages because it is closer, because your delays are smaller, etc. But at the same time, the operational cost of putting something in the sky still in the gravity zone is something that is more mechanical control at this stage. Electronically, there are not major challenges in terms of how it will be for us. So in satellite communications, it is that distance that is bothering us. If you really want to make a payload of an NTN satellite, it is actually kind of a subset of what we have done it in the past, right? For regenerative also. It's just that the distances are so long, the signal becomes so weak. So the power has to elevate, etc. So it's more of those kind of deployment and other challenges that we will have. And truly, the constellation is something that we will have to worry about. So now that we have the experience of cellular technologies, we know how these cells overlap to each other. We will have to put this in a digital twin format and put the whole constellation in place, and then make sure that these the overlays and the interference, etc., are mitigated. But in terms of hardware that people talk about, I mean, if you think about making a regenerative satellite, okay, by itself, is not as tough a task than deploying it and operating it today in an environment that we envision.
Thank you. Thank you.
Thank you.
Yeah,
There is one more question by Ramya Vijay in the chat. Just see the chat and then respond that also, because that may be the last.
public chat. Yeah, public chat. Yeah, I'm seeing Gulab Chand is there.
Ramya,
Okay, Ram. Yeah,
just,
okay. In
yeah, please.
context of 6G channeling model, how ray tracing specially address near field effects, spherical waveforms, dynamic scattering, etc. So, good. This is very good question. In most of the ray tracing things that we have done, we have not done anything on near field. Okay, because all the communication and propagation that we have been doing as a part of channel model is far field only, where the wavefront is uniform. For applications which are near field like your RFID or those kind of or ISEC enablement, we have really not gone to the stage at this stage in at least in the testing part where people have explained us or people have asked us in terms of what do we want to do rigorously in that. So this is what we know as of now.